Good morning, guys. I'm Jenny Kumar here, dealing instrumentation subject for a final year electrical students. Right till now, we successfully completed our first unit syllabus, measuring system and signals and the representation. I hope I successfully completed this topic. Right. Today, in the last session also we briefly discussed about the first unit concepts, right? Today I'm going to deal about the second unit, right? Second unit called transducers. Very important concept for electrical engineers. While doing the instrumentation, definitely you should know the concept of a transducer, right? Now I'm going to start UNIT-2. So what is that? Transducers. First I'll explain what are the contents and what are the chapters that we are going to discussing in this unit. First I'll discuss it. After that we'll start the session, right? Right. The first, so we are going to discuss here. So what is a transducer? Alright. What is the need of a transducer? Alright. Some examples of a transducer. What are the components or components in transducer? Some examples. So this is our first concept. Today we'll discuss about this thing. So we'll discuss, right? So what is a transducer? What is the need of a transducer? And components in a transducer. Some examples. Then we'll discuss about the choice of selection. Right? Which transducer we are going to select for an instrument. So which transducer we are going to take to do the instruments, to do the readings. So that is nothing but choice of selection, which is having some rules. So from this we have to take that the transducers only for need of measurements, right? So after that, characteristics of transducer. Right? Characteristics of transducer. What are the different types of characteristics? Each and every instrument having the characteristic that we discussed. Like that, every transducers also having some characteristics that we discussed. And after that, according to getting output from the transducers are classified into active transducers and passive transducers. But we don't have any active transducers. We'll discuss about passive transducers. So that means different types of transducers. Alright. So what are the different types? So that is nothing but passive transducers, right? A resistive transducer. So what is inductive transducer and capacitive transducer, right? So this we'll discuss in detail through e-lectures, coming sessions, definitely, no doubt about that. Right, after that we discussed about most very important concept, LVDT. Alright, so linear variable differential transformer. This is one type of a transducer which converts a linear displacement into electrical energy. We'll discuss, right? Variable differential transformer. So very important. Definitely you'll get a question. Linear variable differential transformer. Right? In that, we'll discuss about whatever the methods, right? How you can find out the displacement which is converted to electrical energy and all these things we discussed, and applications also. correct? And the last concept is, this is also very very important, so that is called a strain gauge. This is also one of transducer, very very important strain gauge concept, right? Which is also convert the non-electrical quantity pressure, which is converted to electrical quantity. So we'll discuss about what is the examples and all these things, examples, right? Applications, all these things that we discussed. So this is about unit 2. It's very simple and very less topics that we are having. So better if you follow my e-lectures, definitely you will get some brief introduction, brief thing about these transducers, right? I'll explain one more time. What are the first, whatever you want to do, first you have to remind you what are the topics, what are the contents that we are studying. So then only you'll start your subject. Or directly it's very difficult. Directly you go to the question and read the question is very difficult. First you have to understand, so what are the topics in that unit, right? So with this you have a clear idea. So from seeing that you will understand. So these type of questions are very important. These type of questions are rarely we are getting in the examinations itself, right? So that's why my suggestion is, so better to study the syllabus first, right? So then only you'll start your preparation, right? So blindly directly go to the preparation, it's not that much good for your exams, not only for a board exams, for a gate oriented, IAS oriented, for all these exams. First you have to study the syllabus, so then only you'll start your preparation. That's my suggestion for you guys, right? So in this transducer we are going to discuss about what is a transducer, what is the need of transducers, what are the components in a transducers, and some examples in the first chapter. After that, choice of selection of the transducers. After that, the characteristics of a transducer. So according to the output of a transducers are classified into 3 types: passive transducer and active transducers. So these are passive transducers, right? Right, what are the resistive transducer, inductive transducer, capacitive transducers, right? As we'll discuss in detail each and every transducers. After that, the most important concept is LVDT. So what it is also a transducer, how it will working, how its phenomena, and all these things we'll discuss about. LVDT means linear variable differential transformer, right? How the linear displacement which is converted to electrical energy, that we discuss neatly, no doubt about the very very important question. And after that, applications. And the last and final concept is a strain gauge. So this is also very very important question. The gauge formula, gauge sensitivity, and all these things we derived, right? And after that we'll discuss about some examples and application of these transducers, right? This is about the syllabus that we are going to discuss through these e-lectures, right? Today I'm going to discuss about the first concept, what is a transducer, what is the need of a transducer, components in a transducer, some examples that we discussed today, right? What is a transducer? Right? See, each and every electronic instruments, so that it has different components, right? So from this it is having some input, so some functioning, and you'll get the output. So that is my result. So this is the process, each and every electronic instruments. That means each and every electronic instrument that it has different components. So with that, there is an input, some processing, and we'll get an output. So this is the block of a instrument. So how the instrument which is having, so that is having, which is having a mechanical device, that is a measuring device, right? So giving input we are getting output, right? Whatever the instrument which is having, some input and some processing and some output. So each and every instrument from this, each and every instrument that it has how many parts? There are 3 parts, right? So the first part is input signal, right? Second part is measuring device, that is nothing but signal conditioning. So input is nothing but always the signal, right? Signal conditioning or processing. The third one is output, right? So each and every electronic measuring instrument which is having a different components, right? So from this you categorized mostly we are having 3 parts. So what are the parts? That is nothing but input, and second one is a signal conditioning device, and third one is a output device. So the input. So input means, so input is nothing but we are giving a signal, right? So which we want to find out. So that is nothing but measurand, right? Whatever the signal that you are giving to the instrument, so instrument will read something and will get the result, right? So that input signal which is called a measurand. So suppose if you give a time signal, if you give a ramp signal, if you give a pressure signal, if you give a temperature signal, so these are a measurand. There is nothing but input signal. So input is nothing but so the signal called measurand. Right? So that is nothing but input to the instrument. Next, signal conditioning and processing device. The signal conditioning will modifies the signal. So that signal, it can amplify the signal, it can filter the signal, it can modulate the signal according to the function of the device, right? So what is the signal conditioning? It can amplify the signal, right? It can modify the signal, it can attenuate the signal, right? It can filter the signal. So all the things that can be done in a signal processing unit, right? So it can filter the signal, modify the signal, modulate the signal, right? So attenuate the signal. So the function of a signal processing and processing devices is a filter, modulator, attenuated the devices. After that, we'll get the resultant. So that we can call it as an output device, right? Each and every electronic instrument basically different types of components, right? So that instrument we can divide it into 3 parts. So what are the parts? The first part is an input, and second part is a signal conditioning device or a processing device, and third one is an output device. So what is the input? Input is nothing but signal which is given to the instrument in order to find the result, right? This is my signal. So what is the output of that signal? So that is nothing but instrument, right? That signal we can call it as a measurand. Measurand means the input signal which we are giving to the instrument. So that is called a measurand. And second one is a signal conditioning. So what is meant by signal conditioning and processing means which can modulate the signal, attenuate the signal, filters the signal. That depends on a device considerations, right? Depends on the instruments that you are taking, right? If it is a filtering instrument, it will do the filtering the measurand. Right, modulator if you take the modulator, it will modulate the signal, right? Attenuate the signal, like this. The processing output. So whatever the result that we are taking at the output terminal. So that is the 3 parts that we discussed, right? In most of the cases, whatever the signal that you are giving, the measurand, which will be the non-electrical quantity. Right, most of the measurand means the input signal that you are giving, most of that is a non-electrical quantity, like is nothing but pressure, temperature, right, liquid flow, different temperature, liquid flow, right? So these are different non-electrical quantity, right? And most of the output that you are giving electrical quantity, right? So because my output is we require, most of the times we require electrical quantity, like voltage and current, right? So if you have voltage and current, definitely with this you can operate any other instrument, you can operate your systems also, you can operate your load also. So that means the most of the conversion from non-electrical quantity to the electrical quantity, we require most of the instruments. So what type of device that can be used to convert this non-electrical quantity into electrical quantity? So we require a device. So that device we can call it as a transducer. Right? One more time I'll explain. So each and every in electronic measuring instruments which is having a different components, we'll giving a input and we are getting that result as output. So that means each and every instrument that it has three parts. The first part we can call it as an input, and second part we can call it as a signal conditioning or signal processing, and third part is nothing but output terminal. So what is the input? The signal which is given to the instrument, we can call it as an input. So that we can call it as a measurand, right? And what is the signal conditioning? Signal conditioning or signal processing means according to the type of instrument that we are using, that signal is going to be modified. It can be filter, it can be attenuator, or it can be modulator, and all these things, those performance that can be done under signal processing unit. After that, you'll get the result as a output terminal. So that is called resultant. Right? In most of the cases, whatever you do, most of the cases, my measure and my input signal is a non-electrical quantity. So that is nothing but pressure, temperature, liquid flow, rate change, flux. These are non-electrical quantity. Right? So we require the output terminal, always we require voltage or current. If you got this voltage or current, with this you can operate more number of instruments, more number of components, more number of systems. So always we prefer output as a electrical quantity. So for this non-electrical quantity to electrical quantity, we require a device. So that device we can call it as a transducer. I hope it's clear. Right? I'll write the definition here. Transducer. It is a device which converts non-electrical quantity into electrical quantity. We can call it as transducer. Right? So it is a device which converts non-electrical quantity into electrical quantity. We can call it as a transducer. Right? So non-electrical quantity is nothing but energy. Na? Right? It is nothing but energy. So electrical quantity is nothing but energy. Na? So we also define the transducer is a device which converts one form of energy to another form of energy. Right? So why we require electrical quantity at the output means my requirement is electrical, which is more useful for me. So with that I can operate more number of instruments. Nowadays each and every instruments need electrical supply. Right? So whatever the computers, whatever the systems that we require electrical energy. So that's why we are converting it to our flexibility. So that's why we are converting to electrical energy. Right? So one more definition it is a device which converts one form of energy to another form of energy. So we can call it as a transducer, right? So one form of energy, not only electrical, any form of energy, one form of energy to another form of energy, we can call it as a transducer. So according to the transducer output, we can classify different types of a transducer. If output is electrical, so we can call it as a electrical transducer, right? If it is output is a mechanical, we can call it as a mechanical transducer, right? If it is output is optical, so we can call it as a optical transducer. Likewise, the output that you are getting from a transducer, so then we can call it as a type of a transducer. That is nothing but electrical transducer, mechanical transducer, optical transducer. So in this way, we define a transducer, right? So why we require a transducer means, so each and every electronic instruments that we require electrical supply, that we require electrical quantity as an output. So but the input what we are giving is a non-electrical quantity. So that non-electrical quantity that we require to convert into electrical quantity, we require a transducer. That's why each and every electronic instrument we need a transducer, right, in order to operate more number of systems, in order to operate more computer analysis, that all these things that can be done with the help of a transducer itself. Alright, so this is about a definition of a transducer. Now we'll go for some example of a transducer. For suppose, you know the mercury meter. So mercury meter, so which is one type of a transducer, right? So one type of a transducer. For suppose if you want to find the change in temperature in this room, so how you can convert? Is there any process? You don't have any process to find out the temperature. You don't have any methods to find out the temperature, right? So how you can find out the change in temperature in this room? So for this we require a mercury transducer, mercury meter. So how it will work, we'll see. The mercury meter, which is having a fittings, right, glass fittings, right, and which is having some readings. This is nothing but temperature readings, right? And one more column is presented in this. So this column, right? In this column, we are inserted a mercury value, right? Mercury is going to be inserted. So this mercury meter, which is having some scales, right? When a temperature changes, what happens? The mercury, so fit in this column will changes. So that means how you can calculate the temperature, the change in displacement. For suppose if a mercury is here, for a first, so this much length is a temperature. This much length is nothing but this much temperature is going to be present. This is a temperature column. This much temperature is going to be present. If a temperature increases, your mercury is going to be increases. My temperature will be like this. So that means whatever the one form, that is nothing but linear form, linear displacement, linear varying, which is converted to the temperature or a temperature. That means one form of energy which is converted to another form of energy. So that we can call it as a transducer. So the mercury meter is nothing but a transducer. That means linear variations of, you don't have any methods to find out the temperature directly. So for this we require a mercury meter. Mercury meter is nothing but mercury. So mercury will be placed here. When a room temperature changes, your mercury positions will be changed. If the positions will be changed, the displacement you can easily, if the displacement will change. Due to the displacement, your temperature is going to be found out. The varies in a temperature, varies in a displacement. Like this, ఎంత displacement vary అవుతుందో అంత temperature vary అవుతుందని ఈజీగా చెప్పేయచ్చు. So that's nothing but the linear displacement. which is converted to temperature, right? Displacement, which is one form of energy, temperature another form of energy. So this is called a transducer. Alright, and one more example is a manometer. You already studied the manometer. So manometer is nothing but it can be used to find the pressure of a liquid. Right? We don't have any methods to find the pressure of a liquid. So we don't have any solutions for this. For this we require a manometer, which is nothing but a transducer. Right? We'll see how it will work. Manometer, which is having a liquid now. So you want to find the pressure of this liquid, right? You have a U-shaped tube. So that is nothing but a U-shaped tube. One side kept open and one scale is fitted over here. One scale is fitted over here. This is a stand for a scale fitting. Scale which is having some readings. Right? And one side is going to be open and another side which is connected to one pipe which is having a rubber tube. We can call it the threshold pillar, but we don't have that much concept for this. First you should open to the air, so which is having a water level, some water postam anamata, water level postam. Right? దీన్ని ఓపెన్లో పెట్టాం. సో దీన్ని ఓపెన్, ఇక్కడ రబ్బర్, దిస్ ఇస్ కాల్డ్ రబ్బర్. దీన్ని ఓపెన్లో పెట్టామనుకో, air pressure you are finding. That means air pressure means these two liquids are at same levels. So these two liquids are same levels. That is nothing but the pressure of air. సో నేనేం చేయాలి, లిక్విడ్ యొక్క ప్రెషర్ని ఫైండ్ అవుట్ చేయాలి. నేనేం చేస్తున్నాను, దీన్ని తీసుకెళ్ళి డైరెక్ట్గా దీంట్లో పెడుతున్నాను. రైట్? సో ఎప్పుడైతే దీంట్లో పెడుతున్నానో వాట్ హ్యాపెన్, ద ఎయిర్ ప్రెషర్ ఈజ్ గోయింగ్ టు బి రెడ్యూసెస్. ఈ ప్రెషర్ ఏమవుతుంది, రెడ్యూస్ అయిపోతుంది, ఈ లెవెల్ అనేది ఇంక్రీజ్ అయిపోతూ ఉంది. సో దట్ మీన్స్ వాట్ హ్యాపెన్, the scale is going to be varies. So the scale is going to be varies. So this scale will represent the how much the difference from A to B. Right? So the difference in heights, the displacement, the difference in heights will represent how much pressure on this liquid. Right? So and at atmospheric pressure, the both levels are equal na. Right? The scale is going to be shown na. ఎప్పుడైతే దీన్ని తీసుకెళ్ళి వాటర్లో పెట్టావో ఈ లెవెల్ తగ్గిపోతుంది, ఈ లెవెల్ ఈజ్ గోయింగ్ టు బి ఇంక్రీజెస్. దట్ మీన్స్ చేంజ్ ఇన్ లెవెల్స్. దట్ మీన్స్ చేంజ్ ఇన్ లెవెల్స్. ద చేంజ్ ఇన్ డిస్ప్లేస్మెంట్ విల్ రిప్రజెంట్ ద ప్రెజర్ ఆఫ్ దిస్ లిక్విడ్. రైట్? ఎయిర్ ప్రెజర్ ఉన్నప్పుడు సమ్ వాట్ ఆఫ్ 2.3 సంథింగ్. సో ఎప్పుడైతే లిక్విడ్లో పెట్టామో ద ప్రెజర్ ఈజ్ గోయింగ్ టు బి చేంజెస్. ఇట్ విల్ రీచ్ టు 4.6. సో దట్ ఈస్ ద ప్రెజర్ ఆఫ్ దిస్ లిక్విడ్. So this is one type of a transducer. So this is examples of a transducers. Right? So what are that? How mercury meter is working? How the This is a brief examples. You don't have that much concentration on this one. But how some non-electrical quantity which is converted to one form of energy, which is converted to another form of energy. Right? This here one form of energy. So that is nothing but linear displacement, which is converted to pressure. Directly you will get the pressure, but we don't have any methods to find the pressure of this liquid. So for this we require a manometer. So that manometer is nothing but a transducer. Right? So you don't have any methods to find the temperature in a room, variation of temperature in a room. So for this we require a mercury meter. This is one form of energy. One form of energy. So what is that form? సో లీనియర్ డిస్ప్లేస్మెంట్ విచ్ ఈస్ కన్వర్టెడ్ టు ద టెంపరేచర్. ఎక్కడైతే టెంపరేచర్ వేరే అయిపోతుంది, మెర్క్యూరీ ఏమవుతుంది, చేంజ్ అయిపోతుంది ఆ డిస్ప్లేస్మెంట్. ఎక్కడైతే చేంజ్ అయిపోతుందో ఆ డిస్ప్లేస్మెంట్ దగ్గర దట్ మచ్ టెంపరేచర్ గోయింగ్ టు బి టేకెన్. సో దిస్ ఈస్ ద వన్ ఫార్మ్ ఆఫ్ ఎనర్జీ విచ్ ఈస్ కన్వర్టెడ్ టు అనదర్ ఫార్మ్ ఆఫ్ ఎనర్జీ. సో దీస్ ఆర్ ద డిఫరెంట్ టైప్స్ ఆఫ్ ఎగ్జాంపుల్స్ టు ఫైండ్ ద ట్రాన్స్డ్యూసర్స్. రైట్? This is about this session, like transducers, what is the need of a transducers? What is the need of transducers means definitely we require non-electrical quantity which is converted to electrical quantity. If you convert this electrical quantity, definitely it will be helpful for us to maintain different instruments, to maintain different computers and all these things. This is not necessary to convert electrical energy. Right, so whatever the one form of energy which is converted to another form of energy, that we can call it as a transducer. That's it. Right, basically we require electrical energy. That's why one form of energy which is converted to electrical energy. That's it. That's called electrical transducers. Right. This is up to now, and in the next session we'll discuss about what are the different components in a transducers. Right, I'll explain each and every components and with an examples also. Thank you for now.